Right, Assalamualaikum dan salam sejahtera. Alright, today we will continue on the next chapter, which are troubleshooting. Okay, basically what you need to do in troubleshooting. Okay, the first thing you need to know how the components works. These are basically the introduction of it. It could save time. It also can be confusing during troubleshoots. So what you need to know before you troubleshoot is you should know each of the component function. What are they do and how the system works, and then you will know what are not functioning. So the voltmeter indicate the amount of potential between two points. This is calibration for the what is the voltmeter for. The voltmeter is connected across the lamps. This is, and then the voltmeter is connected across the switch. We want to check how much volts are being passed from one point to another point. Troubleshoot with voltmeter. First, understand normal circuit operations. Next, attempt to use jumpers and determine the possible problems. Use jumper for shorting control components. Okay, basically there are methods in troubleshoot the components. The names called hopscotch methods. So basically we jump from one component to another component until the open parts of the component is found. So basically we want to check which one is failure. We need to know which component are open. So we need to find that open component by using this hopscotch method. So how to use it? How to use this method? Basically we'll just leave one part of the voltmeter probes on one side, and the other part will be moved. We check one from one component to another component. So see which one is does not function. Okay. So basically this is compressor circuits, a complete one. So here you could see this is L1, life 1 and life 2. So it goes like this, and here we have a this call it cooling contactor coil. This is relay contactor coil. So this is fan relay we have here, and then fan motors. We have compressor in the middle. So somehow when the temperature reach perhaps the one that you set 24 degree, then supposed to be this compressor is running, but somehow it's not running. So what are the problems? Okay, among the problem that we could just by looking at the schematic, for example, maybe this one is kaput, CC contactor, coil contactor is kaput, or maybe this fan relay contactor is kaput, or fan because it's not running, or maybe the thermostat is kaput, fuse, or this one high pressure switch, low pressure switch, and flow sensor is also kaput because it does not supply current to this contactor. Why need to supply current to this contactor? This is relay contactor coil, because when this is energized, this will make that this contactor coil contactor from normally open to close. It's normally not open to close, so this need to be energized. So if this need to be energized, means it needs current. This need to be function, and so on. This also need to be function. All the sensor in series need to be function. Maybe the compressor itself is kaput, so maybe the overload is open. So this is overload is open, so maybe the start capacitor is bad, or the motor is bad, because this maybe some coil is already burned out and it's open in condition. So let's see how to do Scotch method. Yeah. So to test the compressor control voltage is available or not, there is done by checking 24 volts from the thermostat to CC. So we check from thermostat to this CC whether this is 24 volts or not. Okay. We use jumper to short the thermostat so the current is flowing in the circuits. This is done if the fan motor is operated but the compressor does not. Okay, here what we need to check is we need to check the voltage flow from the thermostat to the CC with the voltmeter. So this is the first method we need to do using hot Scotch method. So we need to connect one probe from the end of the this CC coil and before the thermostat. Here if you get 24 volts means that the fuse is function. Over here this is fuse, this fuse is function. If you get 0 volts means the fuse is defective. Next we bring this probes before or after the flow switch. So and we use this jumper to jump the thermostat, so make sure that without thermostat this is there is always current moving. So if we get 24 volts mean that FL is functioning. If we get 0 volts mean FL is defective. Then we bring the probes to before the FL. If you get 24 volts means LP is in functioning. If you get 0 volt mean LP is defective. Then we bring before the LP, low pressure. If you get 24 volts mean the HP is functioning. If you get 0 volts mean the HP could be defective, because you got 0 volts mean there's maybe this is kaput. Okay. Then what we need to check is check the voltage across the compressor. If 20 to 140 volts, because this is 240 volts. Only here 24 volts because we have a transformer. So if we got 20 to 140 volts means the CC coil is energized and CC contactor is closed and functioning. This one energized and this is become closed and this is functioning. If you get 0 volts means CC contactor does not function because of this, maybe CC coil does not function. Okay, other possible causes when the compressor is not running, compressor winding is open, compressor overload relay is tripped, so we need to change if it's overload relay is tripped. So to check whether there is opening or not in the winding, so we use an ohmmeter. We put one on the common line, another from we switch from one from R to the S. This we got to connected, so we change to measure whether there is continuity or not, using ohmmeters. And last but not least, we could also use ammeters to make sure there is an electricity flowing in the circuits. Don't know whether we got this 240 volt or not towards the system that we have. Alright, thank you very much.